Hi, friend. Today we're doing something a bit different. Not everyone knows it, but I actually got my degree in physics. A few friends just asked me, what do you think about those nuclear fusion news? And I was like, I don't care. It's probably nothing. So what happened is that they overblown it out of proportion. And Rebecca recorded a video where she's like, hey, I think this doesn't make sense. But when she was doing that, she actually made few mistakes. I was thinking like, how much should I research? How much kind of like deep I want to go into it? And I wasn't like a nuclear scientist, so I feel like if I'm going too deep, I will probably start making my own mistakes. So I will probably keep it kind of like surface level so that everyone can understand. And hopefully, she can watch this video and kind of like may make some corrections and stuff.
Oh my God, did you guys hear the news? Breakthrough in nuclear fusion could mean near limitless energy. Holy crap, that's incredible. I mean, that's literally incredible in that it's unbelievable. It is not credible. I do not believe it. Let me start by saying that I am not, this might shock you, I am not a nuclear physicist, but here's something I do know a little bit about. Free energy. Free energy is the idea that you can somehow get more energy out of a system than what you put in. It's also long been a big old scam.
Yeah, I don't know how she got into that. Just the headlines of like, hey, they got more energy out of the energy they put in. It sounds in a way kind of like similar to free energy, but I have no idea how she connected that.
I've seen a new invention pop up at least every few years that claims to violate the laws of physics.
They don't claim to violate the laws of physics. I don't see anyone trying to say that nuclear fusion is free energy device and it has unreal returns. It has pretty kind of like practical returns. So the main idea is that the fuel that it's going to use is pretty abundant. So it's not like getting energy out of thin air, but it's like getting it from heavy water, which is pretty easy to get by.
At the NIF, they're trying a different tactic of firing hydrogen pellets at 200 lasers.
Again, this is just a bit like sad wrong, right? Firing pellets at lasers. So it's kind of like the other way around, but anyway.
Which leads to about 50 explosions per second, which produces heat.
I have no idea what 50 explosions per second mean. I'm pretty sure the laser experiment is only working with one pellet. Maybe like the explosion happens is like in 1/50th of the second, but there is no way yet of like doing 50 explosions per second.
The goal of all of these experiments is to reach a Q of 1. Q is the symbol that scientists use to indicate energy gain, which is just the amount of energy you get out of a system divided by the amount of energy you put into the system.
So I think this is where her kind of like biggest point of confusion is happening. It doesn't mean the closed system. It's not the same as perpetual motion.
So if you get 1 from that equation, that means you break even. If you get a higher number, congratulations, baby, you've got free energy.
Is it wrong that we got more energy out of the system that we put into it? And the simple explanation is no, because apart from the energy the photons like hit the system, you're ignoring the energy that is stored in the fuel. I'm actually like really skeptical about nuclear fusion. So that's why it's so interesting for me to record this video and to provide points like pro nuclear fusion, even though I'm kind of like 100% convinced it's not going to be a practical thing that will replace any other form of energy. I think the best thing that we can do is just to have more nuclear power plants that are just regular fission power plants, because they are the cleanest energy source that we have right now. Will nuclear fusion ever be as popular as nuclear plants or coal plants? Probably not in our lifetime, maybe never, but still, I can get through my own opinions and through my own kind of like biases and say, hey, this is still wrong. You still don't have to say things like it's a free energy, right? You can say that I'm working against my own interest, right? But I think my mission, let's not say things that don't make sense, is more important than this particular application.
So sorry to once again be the buzzkill, but in my opinion, we aren't anywhere near to achieving fusion energy as of right now. I remain skeptical.
I think that the main thing that kind of like rubbed me the wrong way is this kind of like guilt by association of like, hey, there are scams. There are people who are saying that they can get stuff out of thin air. And the way that papers show nuclear fusion, it sounds a lot like those scams. I agree with everything about like practical limitations. Yet, I don't see the nuclear fusion in the same way as like free energy scams. The main thing is that it is spending fuel. It's not it's not catching some kind of like cosmic rays. It's not getting energy out of ether. You're spending the fuel. Each time the explosion happens, you need to put a new pellet into it. So that's why it's so confusing, because Rebecca is saying, hey, they're firing lasers at the pellet. Hey, they're using like this fuel. And then she kind of like completely ignores the fuel part. And it's like, why did you say it before then? It's like, you know that there's a fuel, but now you're saying that getting Q more than one is somehow kind of like controversial. It's not. The energy that you're putting with lasers is basically like energy of the match. And you hope that this energy is actually kind of like negligible. You hope that you are getting so much energy out of your fuel that the part where you lighting up the match is kind of like completely irrelevant. But because how hard this problem is, it's actually not yet irrelevant. It's actually in the same kind of like ballpark, right? So it's like 2 megajoules, 3 megajoules. It's like we're still not perfected this enough to make it into a real practical thing. I think here is where I wanted to show like this thing. If you have uranium or something, it's actually doesn't require you to put any energy. There is such a thing as critical mass. So imagine you have uranium and you're just like putting on your table and you're making it bigger and bigger. Just the act of putting it on a table will cause the nuclear reaction. As soon as you have like enough material, which is like critical mass, the reaction is going to be chain reaction. You can watch on YouTube about people who are handling uranium in, I don't know, like 50s and stuff, and they accidentally put too much uranium together and the reaction happened, all that stuff. As soon as you have critical mass, it will blow up. So it's actually like enough for a bomb just to have a critical mass of uranium, just put it away from each other. And then when the bomb drops, if the material gets together, it will blow up. This critical mass, let's say it's like 4 kilograms or something like that. So what if you want to make a bomb that is 8 kilograms? You can't. You need to do like 3.5 here, 3.5 here. And then when they connect together, you get 7 kilograms and the reaction will start. Because if you have 2 halves and each of them is 4 kilograms, there will be reaction right away. So you need to have 3 parts or like 4 parts and so on. So The bigger the bomb you want to make, the higher the number of like parts that you need to have. And then you need to like connect them all together. So the idea then is that you have something like this and you get everything apart. And as soon as you explode everything from the outside, material comes together and it blows up. But it's challenging to engineer it to make it bigger. That's where the hydrogen bomb comes into place. And if you don't believe that you can put some amount of energy inside this pellet and get more out of this, explain hydrogen bombs. So they have regular bomb, as I was showing before, that's based on uranium, plutonium, all of that stuff. Then it blows up and it starts this fusion reaction. And then this reaction compresses this fuel and it makes it hot enough and compressed enough so that a fusion reaction starts. And if you look into the fusion reaction that they're doing basically the same. They're not using like X-rays from the explosion. They're using lasers that are like compressing the fuel together and heating it up so that reaction starts. This nuclear explosion that happens on the top, it has energy that is like 10 times less than the energy of the whole bomb is going to produce. Why does this system has Q of 10? We are spending the fuel that is inside of this thing in order to get energy of the fuel out. The same way as you're burning wood or burning gasoline, you're making a reaction that will free up some energy that is stored inside the fuel.